Okay, the next topic in section 4.6 is going to be what we've done this before with rational root or irrational roots, things that had square roots. So remember when we had the situation where we had 2 plus the square root of 3 and we had to use all the zeros and write the original polynomial in standard form, so we multiplied them together. And we're going to do the same thing, except now it's the same technique, but we're going to use it with complex roots. So once again, these are all going to have a comment that says something about a polynomial of least degree that has rational coefficients and the leading coefficient of 1. So that means that the a in my polynomial would always be 1, right? So we'll change that a little bit in a later section, but let's go ahead and do this. So an example of this would be, it says, write a polynomial function of least degree that has rational coefficients, a leading coefficient of 1, and the zeros 2 and 3 plus I. Okay, so I know that if I multiply, or from these zeros, I can produce factors and then multiply those together. The problem is that they are only giving me a 3 plus I. And I know, just like when I had the irrational roots, these have to come in the conjugate pairs. So if 3 plus I is a root, I have to scan my root list here, and I would know that 3 minus I has to be added to my list of possible zeros. So now that's a complete list of zeros. And I'm going to go ahead, make those factors, and then multiply those together. So I know that when I make them factors, whatever the zero is, it's going to be subtracted inside the factor. So that would be x minus 2. I would have x minus 3 plus I. And then I would have x minus this 0, the one that's 3 minus I. And there I have my zeros listed as factors. So let's go ahead and simplify this. It's going to be the same technique that we used before. So x minus 3, x minus, this negative distributes into the I. And on the other one, I have x minus 3. And the negative would distribute into that I also, making it a plus I. All right, so now if I wanted to, I can multiply the first factor times the second factor, get a really large number, and then take that whole factor and multiply it by the third factor. That would work. But I'm going to use what I did, the same thing with the irrational roots, and I'm going to recognize that if I can combine or kind of think of these x minus 3s like this, that what I really have is I have a difference of squares. I have an x minus 3 and an x minus 3. I have an I and an I, but I have a plus and a minus. So that's really a difference of squares. So I'm going to work it that way. So the next step would be to say, all right, this is x minus 2, and I'm going to write it as x minus 3 squared minus I squared, and I'm going to work on that. So I've written it as a difference of squares. X minus 3 squared is going to be x squared, the term times 2, minus 6x plus 9. I squared is a negative 1. So when I take I and squared, I get a negative 1, but then that's subtracted, so I'm going to have a plus 1 there. So I'm going to go ahead and simplify that. So I'm going to have x minus 2, x squared minus 6x plus 10. Okay, now I just have to do my normal multiplication. So I'm going to take x times x squared. X times a minus 6x, that would be a negative 12x. X times 10. Now let's move to the negative 2. A negative 2 times x, squared I mean. A negative 2 times a negative 12 would be plus 12x. And a negative 2 times that 10 would be a minus 20. So let's combine like terms. I have an x cubed. I have, let's see, I think when I did this minus 2 times that minus, nope, let's see what I did here. This x times that minus 6 should have been a negative 6x squared. Do I have that up there? Let's try it again. All right, so I got x cubed. Then I have x times a negative 6 is a minus 6x squared. Where did that go? Is this the one that should be a minus 6x squared? Okay, now let's try, that would be 10x, a negative 2x squared, a plus 12x. So I think that's right now. So x cubed, I have a minus 6x squared minus 2x squared, so I have a minus 8x squared. Let's move to the x terms. I have a plus 10x plus 12x, so that would be plus 22x minus 20. And that would be my answer.